welcome everyone. So thanks, Alex, for joining us today. So this is a kind of series of online talks from people from the industry for students to get an idea what kind of broad range of things happening in the industry and their personal journeys and stories and what kind of jobs you might be end up getting at the end. So Alex is a CEO in Urban Data Collective. So he previously lead the IoT team in Digital Catapult. So if you guys know, there are about 9 catapults focusing on different areas. So Alex was part of the Digital Catapult. So Alex, it's for you, I think.
Okay, cool. Yeah. So I sort of prepared a talk around Internet of Things and smart cities. I think that's sort of from what I understand, you wanted me to talk about, right, as an area. So and I've been working in the space for a while. Yeah, so that I've now founded a startup a couple of years back as a spin-out actually from Digital Catapult, which is called Urban Data Collective. And our mission is to democratize access to real-time urban data so others can create better urban futures. So it's really about how can we unlock data from different systems that are emerging in cities or around urban infrastructures and making it more easily accessible. So we provide tools and things, and you'll see later a bit some about it. But yeah, I think the talk again is setting a bit of the context, also based on my own experience and actually what I feel now really matters moving forward for smart cities. Just summarize my personal IoT journey. So I've obviously met Jared. It was during my time at the Catapult, but I started way back as well as a student at that time at the University of Surrey. And after my PhD, I really dived into the area of Internet of Things as part mainly of European projects at the time, exploring this concept. And I was involved in quite a number of initiatives. One of the sort of initiatives that is initially more theoretic research, and then really around testbeds, around IoT testbeds, and also IoT testbeds in cities. And the Smart Santana project, this was actually more than 12 years ago now, was basically our first array into smart cities. And since then, I've been trying to stay in the space, and I've had different types of roles. Obviously, looking initially more from the academic side of research on the IoT, then moving over to industry. So following the sort of R&D cycle from early research to sort of then adoption in industry, like really how can we productize the research that we've done, and then ended up as well supporting a lot of other startups and in the Catapult to adopt new technologies, also build new testbeds, LoRaWAN testbeds across the UK and other things, and ended up then really do my own startup at some point. Okay, so these are all sort of initiatives in Europe you might have come across. So I think Sharon I met as part of Synchronicity, which is sort of towards the very end actually of my sort of R&D journey. But there's lots of other things that we've done in the past. Okay, so in order to better understand, the use of Internet of Things in cities, I think it's good to understand as well a bit about the challenges that cities are facing today, and one of the major ones is urbanization. So we know that already a large number of people live today in cities. London is a huge city, for instance. Cardiff is a smaller one, but still you can see like maybe Cardiff concentrates already a third of Wales. I don't know, I'm just making up this number, but it shows you that people tend to move closer to cities because there's work, there's maybe better infrastructure, there's better entertainment, whatever it is, right? But this trend will increase massively in future, and we expect really within the next sort of like 2-3 decades, 80% of the population will live in really urbanized areas. And that obviously puts a lot of strain on those areas in providing still adequate services, be it transport, be it like access to education, health, whatever it is, right? And some of the issues of urbanization are already experienced by cities today. I mean, we don't have to wait until 2050. It will be just much more worse. So on one side, you've got obviously people stuck in traffic. That's sort of a very big problem across the cities. And how can we actually unlock this? How can we give people back quality of life? Instead of spending time in the car or on whatever transport means, how can they have this time back in their life? The other thing is really around obviously air quality, and unfortunately, a really large number of people live in areas where there is a lot of environmental issues and exposure to air quality issues, and same also looking at, for instance, waste. How can we deal with waste more effectively, or how can we provide convenient transport to other people around? And apart from all those urbanization challenges, we are also hit with many other challenges these days, which obviously just aggravate the picture. So obviously climate change, and what comes with it is like shifting weather patterns, extreme weather, and so on. It's around also like now what we quite well experienced over the last year, maybe excavated now by the Ukraine war, the energy crisis, and how can we as a society, or particularly also in cities, sustain an adequate supply of these energy resources. And then also looking at things like, I think the last 3 years we've been really sort of marked by coronavirus pandemics, right? How can we deal with that? And I think that's not going to be an isolated incident, but there will be many more of these sorts of things happening in future. Okay, so and obviously faced by all these sort of challenges and issues, we are obviously looking for different ways of responding to it. And obviously digital technologies provide one way of dealing with it more effectively. And that sort of like gave the whole concept as well of birth of smart cities. So how can we use digital technologies in different contexts to improve, like how, for instance, people can live more safely secure, how people can better participate within the city, as well as leverage their education or be informed. It's around how can we better run our city administration and infrastructure. It's around how can we enable a much improved needed mobility system in the city to make sure that people get to places they need in the most effective way. It's about making sure that our cities don't remain polluted, but actually become livable places from an environmental perspective, and more resilient to environmental issues, and also how our businesses in a city can thrive, right? So all these sort of things together that sort of makes up a smart city. Okay, and so it's obviously underpinned by digital technologies. There's been already quite a wave of different ones that we've seen over the past decades. And I think the early sort of days of smart city was maybe termed by, or city digitization was termed by e-governance. So how can we sort of shift maybe more services from office-based and paper-based to online? Then I think another bigger wave that emerged was around open data. So how can we open up data from public administrations and make it more transparent and accessible? And then obviously the Internet of Things, I believe, is now the third wave that's really impacting the city. And if you want to look ahead, fourth wave, I think it will be a lot what we do with all this data, like looking at digital twins, AI, and how that sort of can be leveraged as a capability moving forward. But yeah, so just wanted to give you a context of where sort of these technologies sit. And briefly, quick example, e-governance is obviously making sure that public services become more accessible and with less administrative overhead. And Gov UK is, for instance, a great example of this. There's a lot of things now, it's online. Before you had to go to your city office or your sort of administrative county office. Now you can do everything online, right? And you can sort of issue anything from birth certificates to like, you know, applying for like a cost of living support to like, you know, register for unemployment or whatever it is, right? But all these services are now online. And the second wave is really open data. And the idea there is that you can open up data that a city has or that an authority has and make it more easily accessible for multiple purposes. In one way, it's really about increased transparency. So you know what happens, for instance, with your public spending and money, or that citizens become more savvy about the areas they live in and make better choices. Then it's really about also how can we in the local authority better share data. So and that's I think an important part. So making sure that everyone has the right data available when needed, and enable better collaboration for this. And obviously, it's then how can this data also provide value to other businesses to actually create new value for the city or for the businesses themselves, right? And this is sort of what the open data initiatives or wave has enabled. And the London Data Store is, for instance, a classic example of this. And there are many other sort of like now data sharing platforms and data stores emerging in cities. And finally, the third wave is really around the Internet of Things. And here we are talking about adding a new sort of more real-time layer of information to a city. And obviously, you might know already that the concept has been around for a while. It's been initially termed by Kevin Ashton, and it's really about enabling a machine understanding of the real world. So how can we integrate real-world understanding more effectively into the digital world? And what it does in the end enable us is to better respond to challenges in the real world in a timely fashion, right? So in the end, this is what I believe. The IoT has really a key role to play as well in our society, and will become more or less a nervous system of it, right? Where a lot of like businesses and citizens and governments will sort of like be able to tap into, okay? And some examples, and there are many, so I just picked a few of IoT in cities. This is, for instance, an example around how we can increase urban resilience. So, you know, flash floods on roads, or like floods that sort of like emerge and obviously cause a lot of havoc for residents and citizens. And there are systems you can deploy on rivers to measure their heights, systems you can deploy in gullies to see whether they're congested or overflowing. And they then provide a city with an understanding in more or less real time that actually, you know, a flood event is to occur, or maybe that maintenance actions need to take place before actually a flood event will occur. And this is sort of like the sort of new insight that an IoT enabled by different types of sensors in the city can provide. Yeah. But another example is, and because we're still in winter, I thought I want to make it wintry here. Okay, so it's also how we actually grid our roads and make sure that they are safe, but also doing so in a very cost-effective and environmentally sustainable way. And again, instead of just listening to weather forecasts and sending out your fleet of gritters to grid every corner of your county, people are now slowly resorting to sensors deployed at roadsides or major roads that can actually tell what's the road surface condition, and then through this make sure that the bridging vehicles are dispatched to the right areas of the road segments, and only to those that are actually needed. And that provides you obviously with cost savings, but also it avoids you to throw needlessly grit or salt onto the street, which has cost and environmental implications. Okay, but these are some things just to give you an idea of where IoT is sort of like being used and heading into. And yes, so now I'm sort of becoming a little bit more technical. So all these sort of things that I just shown are obviously systems that are typically composed following a quite typical layered architecture that I presented here. So you've got At the bottom layer, different IoT devices, which are like sensors or sometimes actuators that are able to measure the real world, what's happening, so in their surroundings, and then report this information back, or maybe even influence what's happening in the surroundings, like if they're actuators. And typically, those devices then connect often wirelessly, sometimes wired, via networks, and different types of networks back into some sort of service backends or platforms, often cloud-based, which then in the end provide then decision makers or services the right insights to act upon it, right? So that's a typical layer. And what's interesting to see is like there's quite a large diversity in each of those layers emerging today in industry. So there are actually thousands of IoT devices now out there. And obviously they are there because they sense different things and they're for different purpose sometimes, but obviously sometimes they're just competing devices. Then there's tens of different connectivity technologies out there that one can choose from building in IoT systems, and there are hundreds of different IoT platforms as well, which obviously causes a little bit of challenges as well for the industry when you start adopting such technologies. And I will talk about this in a minute. This diversity obviously is still needed, and I'm just taking now an example on the network layer, because different IoT deployments and applications might have different requirements. So some of them might be maybe requiring connectivity over larger areas, while others they are more constrained to specific areas or buildings, but might need to penetrate walls and so on. And there might be use cases where sensors are reporting a quite high amount of data, while in others it's just event-based and sporadic. And in some cases you need quality of service and reliable delivery, in others not. And so there's always a trade-off. And because of this trade-off, there are also different types of technologies deployed. Okay, and I'm not going to go into depth and detail. I think Charles will cover a lot in his lectures, I think. But yeah, just to give you an idea of why there is this diversity. So there's no one size that fits all. And what it means in the end is that a lot of different sort of vertically integrated IoT solutions are now emerging in cities. So, you know, for instance, a solution on parking that is based using LoRaWAN, and obviously is able then to collect data from smart parking sensors effectively into a management application that then potentially is hosted on an AWS IoT platform, right, as an example. In another case, it could be like people counters, which are strategically deployed on high street, which measure people flow using NB-IoT. In another case, it could be like fill level sensors of bins or tanks, which are reporting back by a Sigfoxer, and so on. And what it means is you've got a lot of different vertically integrated solutions now emerging in cities, which on one side provide certain benefits, but on the other side are still limited in terms of the challenges they're able to address and face. And what I'm trying to say here now is, while there's a lot of talk about IoT infrastructure, and I think IoT infrastructure is really essential to be able to get this real world data, right? It's just a utility. And the real value in the whole IoT system is in the end around the data that is being collected and how this actually data can be turned into insights and actions that make a real difference, you know. And so and if you look at the sort of complex challenges that we have now, like for instance air pollution as an example, you can just work with an air, you know, data just being in a dashboard telling you how bad the air quality is doesn't fix the problem. So you need to start actually working with such data and maybe other data of other systems to really innovate and provide a solution that effectively works. And that solution can be, you know, a solution that is a mix of things. It could be a service. It could be also different policy actions that you sort of need to implement to encourage behavior change. It could be very complex in the end as a response, okay? And I feel that as a city or a smart city to really sort of like tackle those complex challenges, you need to more effectively work with data across different types of silos and systems. And a lot of this is currently, unfortunately, not happening because data is locked in these silos, and this stifles a lot of innovation in this space. Just giving you an example now here, and that's a more recent project that has been carried out in south of London. And here we really looked at how can we actually solve the problem of air pollution and congestion. And in this case, what you really had to look at is bringing a number of things together. One of them is like traffic data, as well as data from around air quality that is caused by it. And so understand the cause and effect a bit more. But then it's also how can we then use this data and adapt, for instance, other control systems that exist, such as, for instance, traffic lighting, to actually then control traffic flow so that actually real change can occur in the real world. And in this pilot, what was demonstrated is actually by adapting smartly traffic light systems, one could increase the average speed of cars and throughput of the road network, and then reduce the air quality and improve the air quality or reduce air pollution tangibly. So what it shows you, this simple example, is actually you need data from multiple systems and then drive other systems in turn to really have an impact in the road. And I don't have to talk about like the benefits of just more opening up and sharing data. I mean, a very leading example is Transport for London. As they open up data about train information, real time, and tube and buses, actually they managed to encourage a lot of innovators around, such as City Mapper, Waze, or others, to leverage this data to then provide services for free to the public or through some other business models, but which in turn actually help them achieve their objectives and save a lot of money for basically, or is even create economic value. And this is the power of data sharing and what the data sharing enables. But obviously there are challenges around sharing data, and those challenges are really that it's about the lock-in of data in different systems. Because as I say, solving complex challenges such as urban planning or net zero transitions or like pollution reduction or how to increase our environmental resilience can't be solved with a single system. You need to have this data across multiple systems and work together. However, there is currently a reluctance often by the also system suppliers to open up data from such systems, because obviously they want to sell a service and make money, and they have to deploy devices that deliver the data, and it's an investment they make, so they want to also retain the value of it for their own business. But their objectives are different than the objectives of the cities or the final end users. A city doesn't want just to have a smart dashboard to look at. They want to more flexibly work with this data to actually then give it to a consultant to solve the challenge they're facing. And that sort of is where we are currently at the moment. Yeah? And an initial attempt by the market or the industry players is really, okay, can we remove some of those silos? And I've shown you, I think, in this previous speaker, like currently you've got all these standalone sort of like systems, and how can we then open up data from the systems more effectively? And there are players, for instance, on the market, big cloud providers or big ICT companies or consulting companies, who then say, okay, we'll bring all this data together from all places in one system. And then in a common, what I call IoT platform or service platform. And then we will build you different applications and dashboards that you need. Yeah. In the end, however, you're creating another lock-in scenario, because you can't just choose to have a dashboard from another provider, but you now need to work with this consulting company who's built a platform to enhance it, and they're charging you based on that. The other example is actually even going further and even take over the connectivity piece, which is for instance, bigger telco operators like Vodafone and others are doing, where they say, we provide you with a complete managed service that includes a service platform and even connectivity. And again, although they solve the data integration issue from different devices to a certain extent, you will end up stuck in their ecosystem again as a provider. And that's a challenge. So in the end, there are two sort of challenges that are sort of described here. One I call city vendor lock-in, and the other I call developer city lock-in. And I just explain you what I mean with that. So on the city vendor lock-in case, obviously you are then stuck with a particular platform or a choice of standards or of non-standard proprietary sort of interfaces and systems that make it difficult then, as you are developing your smart city over the years, to add new things without being dependent on the existing supplier. Okay. And then on the other side, that's sort of like an effect that is emerging, that as every city works with different suppliers that provide technologies that are proprietary, every city environment starts to look slightly different. So if you want, as a service provider or data-driven service provider, scale from one city to another, you are faced with another environment, so another sort of like effort to reintegrate into this new environment, rediscover relationships with different maybe data providers, and you need to adapt your APIs to other APIs and data sources and so on, and all this together causes challenges again for a company to scale, and so that these two sort of like what I call challenges really are currently holding back the whole smart city market to really scale well across different cities and areas. And there are a few cities across the world, nearly 170 to be exact, who have actually come together now over the years to solve this lock-in challenge a little bit more. And they're called Open and Azure Smart Cities. And they're working really together on creating some foundations for a local data sharing ecosystem in cities. And the idea is, can we agree on specific common interoperability standards and mechanisms or guidelines that every city will implement, so we can then create a more harmonious common data environment that allows us then to leverage solutions across cities that work in other cities much more effectively. Okay, and as part of Open and Azure Smart Cities, we have basically different types of working groups and activities that look at different so-called minimum interoperability mechanisms, and they really include a range of issues on how data in cities will be accessed, so their APIs, how data is represented, so in information models, how data can be exchanged and discovered, so an ecosystem or marketplace, how personal data should be managed in cities and can be accessed and shared, how can we assess and provide guidelines for algorithms who are in cities, so we know they're trustworthy and fair. How can we ensure that cities' solutions are secure and obviously we mitigate certain risk of cyber attacks or leaks and other things, and so on. So different sorts of issues that are being discussed and harmonized, and where cities then come together and agree on a common approach that we want to implement. And three of the sort of like the first three of the approaches are something that we are actually concerned with now in my business and daily life, and I want to share a little bit more about it with you. One is sort of quite essential. It's around how data and information can be accessed and shared in cities. And currently, two proposals that are, or the starting points for the cities are on one side, NGS ILD as a context model and API, as well as smart data models as a way to represent data. So these are sort of initial standards that cities have started to use and adopt and agreed to take forward. However, there are also concerns currently in the community that just those two are a little bit limited and more should be included. Okay. And then the other thing really deals around like more the ecosystem, which is actually where one of our offering really sits in firmly, which is how can we manage effectively a local data ecosystem? And it's really around how data is discovered and represented, how data is acquired, how data is licensed, and how SLAs are defined, how SLAs are tracked around data. It's around how the mechanisms for trustworthiness, such as feedback and reputation. And it's also around like how you can monetize data. And also maybe interlink different local ecosystems like that across the list. And the proposal was there put forward around some APIs, which are, I guess, quite ancient and have sort of the firming more in the telecom sector, but they're quite complex to implement. So there's still other conversations going how that could look like, but at least the sort of capabilities and functionalities are currently agreed in this space. Okay, which brings me a little bit to Urban Data Exchange, which is an example of how this sort of data ecosystems can be implemented. And this is actually a product that we developed. And it's in the end what I call a data sharing layer that enables real-time data collaboration in cities. And it's not yet another IoT platform, but you can imagine there are loads of them out there. There are hundreds of them on the market. Cities may have them or partially have them, but it's rather a layer that brings real-time data streams together in one place and makes it more easily discoverable and manageable. So it can be effectively used with inside of an organization or a wider ecosystem of partners. And so, yeah, it's basically a SaaS platform that simplifies management, use, and sharing of live urban data streams. And you can think of like different city systems or providers of them plugging data into it. So it becomes then discoverable and shareable. So access to the data becomes discoverable and shareable within a city department or with third parties. And here it's really around making sure that all the data becomes accessible in the same way. So really, using the minimum interoperability mechanisms agreed within the open access smart city community. So how can we make sure the right metadata about the data is there? How can we ensure that air quality data or traffic data can be accessed in the same way, regardless of the supplier of the system and regardless of the city where the system sits? And then it's also around all mechanisms that you need to make sure that data users can discover, access, negotiate access to data, license data, monetize data, and also manage trust around the ecosystem. Okay, and yeah, so just a little deep dive. So in the end, any type of systems that you have on the left, be it like an existing IoT or proprietary systems, as long as it has some sort of API, we can make them compliant to the MIMs, so that to the minimum interoperability mechanisms, and then expose through the UDX API in a harmonized way. And on it, you also have a lot of metadata around, so you can see exactly what type of payloads will flow through the system. You've got an API that is well documented. It can be used then to query, inquire, and which follows basically the standard specifications. And then it's also around like bringing all data streams together in one place to make it discoverable. And so you can see all your data streams that an organization has in one place, be it like coming from traffic sensors, air quality sensors, noise sensors, pedestrian sensors, but also you can choose to share those streams not only within your organization, or on your profile, but you can also publish it onto a more global marketplace where the data in your city certainly sits alongside, or in your organization alongside data of other cities and other organizations, and becomes discoverable to a much more wider community. And within it, you've got different types of metadata, so data that tells you more about the data stream. So how many sensors are actually behind now? Let's say there's a traffic data stream, and there are like 180 traffic cameras which are distributed across the city, or it's maybe a charge point data feed. So how many charge points are there, and where are they located, and how does the data look like, and how often is data being reported, and so on. And what are the licenses and terms to be able to access this data? And is it a public data license, or is it maybe a data sharing agreement that comes with it? And you can define those sharing terms on our platform, and as a data user, discover those sharing terms and sign up to them if you think they are the right for you. And then you can also share and control access. So basically, you might want to publish the data and make it discoverable, but you might not want everyone to access it straight away, but you want first to vet the data user. So someone needs to request access first before you actually allow them to access the data streams, for instance, and how to support these types of workflows. And it's also around like negotiating access, right? So in the end, making sure that once you acquire access, you sign an agreement or a license, and this is being tracked on our platform. And then it's also around how reliable is a data stream. So, you might have possibly 100 air quality sensors that you want to use, but possibly half of them don't work or have fallen over the last 3 months, or some sensors are flaking in and flaking out of the data streams. So these are just some examples, again, which are quite tangible, which often occur and our platform manages. And then an interesting thing is also about how you share data with other organizations. So is it just within your own space, or is it by publishing it to a global marketplace that I mentioned? Or maybe I want to create a data commons or a shared data space between multiple organizations, which is only visible to them. And that sort of things is something that, let's say, a local data ecosystem can finally support. And I'm just going to end with a few examples. I know, Chara, so I hope I have 5 more minutes. Is it okay? Or
yeah, that's fine.
Yeah, cool. So so that's basically an example. We're working with Surrey County Council, which is in south of London. So a council which basically has a number of IoT initiatives on the ground, deploying all sorts of sensors, anything from parking, weather, energy use in buildings, and so on. And instead of just using the data within their own sort of like supplier provided dashboard, they are onboarding this data onto UDX. And now we can actually start working across this data to solve some of the challenges that are more tricky for them to face. Another sort of example of our collaboration is with a network of actually also universities called the Urban Observatories. So these are Newcastle, Manchester, Birmingham, Sheffield, and now actually Hull City joining in as well. So these are all, I would call like organizations who have brought together a large number of data streams from their specific environments about the cities, for instance, and are managing this sort of data on behalf. But although they work together on the same sort of initiatives and projects, they ended up all building different types of what I call data platforms. The APIs are slightly different, the data models are slightly different, and actually, if you want to start exploiting this data combined across those sites, it becomes a challenge, because suddenly you have to deal with 5 different types of APIs, even for the same type of modality, sensing modality, to develop a service. And here we are actually in a pilot together that involves DFT as a end user. We're bringing together real-time data about traffic and air pollution across a larger UK area, so it can be they can use it for more timely decision making. And again, you can see each of these different environments now having their own platforms, their own APIs, and where UDX plays a role in providing a more harmonized access across these separate platforms and data spaces. Okay, so sort of concludes a little bit my talk now. So I hope I could give you a feel for that IoT systems play a key role really to provide new insights for citizen regions. Obviously, they provide the real-time data that is needed to take more more timely decisions and more smart decisions. But it's the infrastructure itself is just a means to an end, and it's actually what you do with the sort of data from the infrastructure that really matters. And unfortunately, in the current world, a lot of this data is locked behind the sort of proprietary systems and infrastructures that are there. And in order to really take fully advantage of it, you need to create a local data innovation ecosystem that requires data to be shared across the systems. And this is obviously what we are addressing as a company with the UDX solution. And there might be others obviously out there that are moving to this space. But yeah, so yeah, I hope it was an interesting perspective now from the industry. Thank you.
Thank you very much, Alex. I have a few questions. I will maybe go straight away, then I will let the students to ask questions as well. These are for students as well. So Alex, you initially mentioned that you went through from academia, and then you basically proceeded into a PhD, and then do more research and went to industry. So what is the key difference that you say? What is the mindset, or how somebody would adapt? What is your advice in that case?
So if you want to shift from academia to industry, you mean? Yeah.
Yes. So our students now, I mean, haven't gone through as much as you in academia, as the bachelor's or master's, but there's somebody might go to PhD, but eventually they go to industry. So what is the main shock or different that you observed when you're moving to the industry?
Good question. I mean, obviously, my transition has been not gradual. So I wanted to work in research. That's why I sort of went for a PhD initially, and then academia is a good place for it. But I decided to but in academia, you can only stay for a certain amount of time until you off to the next thing again, and the next thing. And if you really want to make sure that some of the research becomes reality, you need to at some point transition to applied research, to actually innovation with it, right? And so I followed more this cycle. And I also placed myself initially in a research division of an industrial player where the shock wasn't this big. But then obviously once it becomes more, I guess, more applied, there is a difference. But yeah, okay. Answering your question, I feel that. Depending on what you do, I think it's a lot less sort of like theoretic. I would say it depends on your role, right? I think again for you can end up in different types of industry roles, right? Some of them are very maybe. Let's say if you're talking technical, right? They could be more sales oriented or pre-sales oriented. They could be more development and implementation oriented. It could be more R&D and research oriented, and within there are different cultures, obviously, right? That you have to adapt to. Different types of people. Like in a sales oriented role, are more business people, and maybe the rhythm is different than if you were to sit behind and develop code, right? So I think so there's a broad spectrum of roles, and each of them has a different sort of environment. So tricky to say. There's a culture shock, but I think if you come from research to innovation, it's the speed that you have to adopt. I think it's much more fast paced and much more shorter cycles and much more shorter term thinking. Yeah.
Thanks, Alex. My second question following up. So if you go back to your bachelor's time, and if you have to give your advice to yourself, what would be the key things that you want to say to yourself?
It's very personal, right? So I think everyone has to sort of take this with a pinch of salt. But I think I would have after my undergraduate or master's, I would have jump straight away, I think, into some entrepreneurial role. So I mean, I think, yeah. So I think I thought, you know, obviously doing a PhD and the research environment was really helpful for my development, and I enjoyed it for a long period of time. But in the end, I think I would have jumped straight in and tried to solve an issue like with a startup or something like this. But this is a very personal thing, right? So yeah.
Yeah. Okay, thank you very much. So the next question is more about IoT. So IoT is kind of a vague term, and then I mean these days you sometimes see like people hiring IoT technologists and this kind of like IoT in the job role, but it's not very clear, or because it is kind of new. So you probably have involved in some of the hiring processes of kind of with the IoT in the title itself. So what kind of skills that students need to develop themselves to prepare this kind of very specialized job? I hope there's a kind of a spectrum of jobs.
Yeah.
But can you share any kind of particular example that you have been involved in? What kind of things that you looked at?
Yeah. So I think so broadly, I think if I sort of segment this, right? So if you're really looking at like an environment which is more development oriented, right? Let's say you want to join a company that builds an IoT product or a product in the IoT space, right? I think what you really need to have is then necessary software development skills, and ideally experience in working in a commercial sort of setting and environment to develop software or become very productive very quickly, right? In this kind of space. So it's not so much about knowing all the standards ins and outs, but it's more really being able to quickly at some point produce quality code. You know what I mean? Or then there's obviously the roles where you do maybe more deployment oriented, but more hardware oriented roles, you know, where you need to apply again your learnings into sort of like manufacturing processes or design processes. Yeah, so I think the sort of IoT generalists that you sort of are taught in university often might appeal more research environments, right? You know, where or like R&D centers or something like that, or maybe R&D environments of corporations, right? But I think if you want to, and then there's obviously the software development track that you really need to have skills in, and then the other thing I would say is the data science piece, right? Working with IoT data and having insights around that as well. So that's maybe being able to create, you know, new models, new algorithms, new things around data. So that's sort of another track I would say is something quite valuable if this is where you want to go to, right? Yeah, but I think it depends really on the sort of company where you want to end up.
Thank you, Alex. I'll open the floor to any students to ask any questions. Do you guys want to type any questions, or you can unmute and ask any questions? Alex, thank you very much. It's very insightful for us to get your perspective and the industry perspective, because we kind of in the research, so we see one side of the story. So it's good to have to see how the industrial perspective. So thank you very much.
No, thanks for having me. Really, it was great to see everyone here, and yeah, I mean, I wish you all best of luck in your sort of like journeys, wherever it's heading, and yeah, I mean, it's an exciting time. It's a good place to be in, and yeah, good luck. Okay.
Thank you, everyone. Thank you, Alex.